Hello everyone, I am going to present my paper titled Performance Improvement in 6G Networks using MC-CDMA and mMIMO. The main objective of my research is to improve the performance in 6G wireless communication networks using MC-CDMA and mMIMO with the help of emerging technologies like underwater acoustic channels, visible light communication, terahertz communication, large integrated surface, artificial intelligence, machine learning, holographic beamforming, and blockchain based spectrum sharing. Next, we will have a small introduction about the evaluation of wireless networks and IMT 2030 requirements. The invention of wireless telephony leads to the first generation of wireless communication networks in 1980s. After a decade time, the invention of GSM leads to the second generation of wireless communication networks. Development of UMTS across 2000s paved the way for third generation wireless communication networks. The fourth generation wireless communication networks started in 2010 with the design of long-term evaluation and WiMAX. IMT 2030 requirements have paved the way for the research towards 5G and 6G wireless communication networks. Next, we will have an overview of massive mMIMO. Basically, massive mMIMO remains to be a promising technique that supports all the requirements of IMT 2030. The notable merits of massive mMIMO when compared to the conventional mMIMO are spectral efficiency, diversity gain, multiplexing capacity, and energy efficiency. Next, we will have an overview of MC-CDMA. MC-CDMA is a multiple access scheme generally used in OFDM based telecommunication systems, which allows the system to support multiple users at the same time over the same frequency band. Massive mMIMO along with MC-CDMA has become the backbone for several network companies across the globe. One such company to merge these two techniques to implement its network is NTT Docomo. The network has achieved a 5 gigabits per second transmission rate at a traveling rate of 10 km per hour using 4G protocols with a frequency range of 100 MHz. Further, 12x12 massive mMIMO configuration is being deployed in this network. Massive mMIMO overcomes the limitations of mMIMO by providing enhanced throughput, improving energy efficiency, increasing the distance of coverage. Regardless of its features, massive mMIMO is limited by the uncertainty of channel, variation in channel capacity, and reduced reliability. To overcome the drawbacks of massive mMIMO, proper modulation technique is to be deployed. Out of all the modulation techniques, MC-CDMA supports all the requirements of massive mMIMO, and hence we have concentrated all the possibilities of deploying MC-CDMA along with mMIMO in each one of the upcoming 6G wireless communication technologies. Hence, MC-CDMA and mMIMO remains to be a promising technique for future wireless communication networks. Let us see the future technologies that hardly requires these two techniques for improving their performance one after the other. Initially, we discuss about implementing MC-CDMA and mMIMO in underwater acoustic channels with the help of machine learning and artificial intelligence. Furthermore, we will discuss the role of massive mMIMO and optical CDMA in improving the performance of visible light communication. Moreover, we will illustrate the implementation of nano antenna arrays along with massive mMIMO in terahertz communication. Likewise, we will discuss the possibilities of deploying massive mMIMO in large integrated surface. To a little extent, we will also discuss about the need for artificial intelligence and machine learning in the upcoming 6G wireless communication networks. Further, we will explore the features of holographic beamforming. Finally, we will have a brief discussion about blockchain based spectrum sharing, which is an emerging technology which could replace the role of the existing internet. In order to provide high-speed internet connection between continents, wired communication undersea becomes mandatory. Unfortunately, wired communication becomes costly and complex to maintain. Apart from internet communication, There are many other applications that hardly needs a proper modulation techniques, which includes sightseeing, underwater life research, disaster prevention military, autonomous underwater vehicles transportation, and much more. Hence, wireless communications with reliable modulation techniques becomes mandatory. CDMA, along with many machine learning algorithms like deep neural networks, have proven to improve the performance of underwater acoustic channel communications. In order to provide uniform and effective communications under sea, many nodes based on mIMO and CDMA are placed uniformly across seas. These nodes are effectively controlled by artificial intelligence based master nodes. In spite of their limitations including limited battery power, limitations in bandwidth usage, reduced sensor life due to corrosion, a large amount of energy absorbed by water, it still remains to be a promising technique, and hence there is a high demand in the near future as it reduces the cost of laying wires for undersea communication. Next, we will see about visible light communication. Generally, white LEDs are used as transmitters and photodiodes are used as receivers in visible light communication methodologies. The visible light communication has greater attention in the recent days for the development of 6G and beyond wireless communication systems because of its three major properties as discussed below. Firstly, it can operate in normal visible spectrum and hence there is no need for spectral license. Secondly, it can achieve a huge data rate in a transmission that is unimaginable. Finally, it is free from collision as electromagnetic waves cannot affect this communication. VLC can be deployed based on a CDMA based system employing two major methods, namely unipolar codes and bipolar codes respectively. Additionally, optical CDMA codes can be used in the implementation of VLC for indoor localization systems as circuit design complexity is less and hence the cost of implementation will cheaper when compared to other modulation techniques. Further, mIMO based VLC communication proves to be a promising technique to fulfill the requirements of 6G and beyond communication techniques as it can transmit data up to 1 GHz in indoor communication. In the near future, it can be optimized to work in the outdoor environment with the help of artificial intelligence based protocols. Next, we will discuss about terahertz communication. In spite of short distance communication properties due to propagation loss and restriction to power, terahertz communication is still a promising technology for 6G and beyond wireless communication as it can provide a high data rates when compared to microwave and millimeter wave bands. To overcome the drawbacks of short distance communication properties in terahertz communication, we can deploy massive mIMO in the existing system to increase the performance of the terahertz band. But developing antennas for providing such a huge frequency communication is being a bottleneck, and research are still going on to design antennas that best suit for this massive communication. Recently, there are several researches which are carried out based on nano antenna arrays and are developed and tested successfully for this high frequency bands. Next, we will have an overview of large integrated surface. Large integrated surface contains an array of reflecting elements that can be fixed easily in walls of buildings so that it can reflect the signals to the users from massive mIMO antennas. By means of doing so, it will be easy for the base station to establish a communication with the users who are in the blind spot regions. On implementing large integrated surface, the gain of massive mIMO system increases with less consumption of power during transmission. By means of implementing this technique, interference will be reduced to a large extent so that it can be used in indoor as well as outdoor environments effectively. Additionally, it can also support technologies that is far beyond massive mIMO. Next, we will see how artificial intelligence and machine learning helps in improving the performance of future wireless communication networks based on massive mIMO and MC-CDMA. In order to select the perfect protocols and technique, we need a lot of instant calculations and predictions to pick the right one. For this purpose, a special methods based on AI has been developed. The AI protocol and techniques were further charted out, and a platform was defined for developing AI codes based on network demands. There is no doubt that AI is going to take over the wireless networks shortly. Next, we will have an overview of holographic beamforming. In the holographic beamforming methodology, the signal strength from the base station with software-defined massive mMIMO antenna is directed towards a particular user instead of broadcasting in all directions. By means of doing so, we can achieve large throughput in the range of gigabits, improving signal-to-noise ratio, and transmitting power is much reduced, and even it can increase the coverage area. Even though space division multiplexers is being deployed in holographic beamforming, multi-carrier code division multiplexers can be deployed in the subcarrier transmission of signals, and thereby the overall performance can be optimized. The advantages of using holographic beamforming are they are very cheap in manufacturing, they occupy very less space, they are weightless, and works with less power. Next, we will see an overview of blockchain-based spectrum sharing. Blockchain-based spectrum sharing is a decentralized form of sharing data among users by spectrum sharing, which could perform the same function as the internet. They are categorized to operate under licensed as well as unlicensed bands. For effective improvisation, presence of nearby node is identified and the spectrum is allotted. The primary way of operating is by users finding possible ways based on the mapped information available in the decentralized database and choosing the right way to communicate. Before communication, users need to share usage rights among each other for efficient communication. To optimize the payload, applying massive mMIMO will increase the performance. Further, MC-CDMA can be used as a modulation technique for transmitting the data among users in the decentralized network. We have presented the roles and opportunities of MC-CDMA and massive mMIMO for 6G wireless communication and even beyond that. There is no doubt that above mentioned 7 technologies along with MC-CDMA and massive mMIMO will improve the efficiency of 6G wireless communication networks. Furthermore, most of the technologies discussed above have proven to enhance their performance on merging with MC-CDMA and mMIMO. We hope that the presentation makes a clear outline for those who are willing to start their research in 6G based wireless communication techniques that are based on MC-CDMA and mMIMO. Thank you.